A 25-year-old Honda is selling for $60,000. It left the showroom in 1997 for $22,900. No other front-wheel drive car at any price has ever done that. The market has taken its time reaching this conclusion, but the verdict is now clear. Honda accidentally built something too good for their own bottom line, and then quietly killed it before anyone noticed. In 2001, the DC2 Integra Type R left production with no press release and no farewell. Just a final run of championship white coupes leaving the Sayama plant, each one carrying hand-finished cylinder heads that no other production car at any price was receiving at the time. The question that runs through this entire story is a cold one. How does a company build the highest expression of its own engineering philosophy, prove it works, and then walk away from it? To understand the DC2 Type R, you have to go back to a racing program that ended 4 years before the car ever reached a showroom floor. From 1988 through 1992, Honda supplied engines to the McLaren Formula One team. Those were the years of Ayrton Senna and Alain Prost, of championships won by wide margins, of a partnership that produced one of the most dominant stretches in the history of the sport. Honda's engineers weren't just supplying horsepower. They were developing internal methods for building naturally aspirated engines that revved higher, breathed more freely, and held tighter tolerances than anything available in road car production. When Honda withdrew from Formula One after 1992, those methods had nowhere to go. Think about what that meant for the engineers inside Honda. They had just conquered the world alongside Senna. They had built engines that rewrote what a naturally aspirated motor could do. And now, the program was over. The rebellion didn't stop. It just needed a new form. The standard production Integra didn't need hand-finished cylinder heads. It didn't need individual throttle bodies or tighter valve clearance tolerances. A commuter car built to volume and margin targets had no use for race engine preparation techniques, and no product planning budget that could justify them. So, Honda created a mechanism. The Type R program was the answer to a specific internal question. At what volume does it become possible to apply motorsport manufacturing to a production vehicle? The answer, it turned out, was a very low volume, just enough to justify the process, just enough to make it real. The mid-1990s gave Honda the right competitive moment. The Mazda Miata was the benchmark for driver engagement at the entry level, a beautifully sorted roadster with no roof and genuine rear-wheel drive balance. The Honda Civic Si offered everyday usability with a sharper edge. The Toyota MR2 Turbo brought forced induction and mid-engine dynamics into the same price range. Each of these cars had a clear strength. None of them offered what Honda was about to offer, which was a factory-built, naturally aspirated, high-revving front-wheel drive coupe, assembled to race engine standards and sold for under $25,000. The pricing was a deliberate discipline. Honda launched the DC2 Type R in 1997 at approximately $22,900. The standard Integra GSR sat just below that. The gap was modest, and Honda kept it that way on purpose. The directive wasn't to extract maximum margin from an enthusiast willing to pay. It was to keep the Type R accessible to the buyer it was actually built for. That buyer existed because of what Honda chose to do with the car's assembly. The Type R was built at Honda's Sayama plant in Saitama Prefecture, Japan. Not on a standard moving assembly line where each worker performs one operation and the car passes to the next station. Each B18C5 engine was assembled by a designated technician who completed the full engine build from a stage component set. One technician, one engine. The cylinder head received port polishing before assembly, a process that takes hours per head and exists in almost no other production car at any price. This wasn't cottage industry. The Sayama plant used Honda's tooling, Honda's fixtures, Honda's quality systems. But the accountability was individual in a way that standard volume production never is, and that individual accountability was the foundation for everything that made the car remarkable. Honda built approximately 3,381 of these for North America across 5 model years. By any measure of production economics, that number makes no sense for a mainstream manufacturer. It made sense only if the car's purpose was never volume. Its purpose was proof. Proof that the methods existed. proof that the philosophy was real. Proof that a $23,000 coupe could carry the same engineering intentions as a championship-winning race engine. For 4 years, it did exactly that. The engine that powered the DC2 Type R was called the B18C5, 1.8 liters, 4 cylinders, no turbocharger, no supercharger, nothing forcing air into the combustion chamber except the pressure differential created by the piston's own downward stroke. Most people point to the VTEC crossover as the magic of this engine, and they're not wrong. But they're not seeing the whole picture either. The real reason the B18C5 survives 8,400 RPM without tearing itself apart isn't in the software. It's in a physical preparation Honda carried directly from their Formula One program, one that no other production car at any price was receiving at the time. That detail comes in a moment, and it changes how the whole engine makes sense. From that naturally aspirated 1.8 liters, Honda extracted 195 horsepower at 8,000 revolutions per minute, with a factory redline of 8,400 revolutions per minute. That redline is the highest of any Integra variant ever produced for any market. The standard GSR's B18C1, same displacement, same basic architecture, redlined at approximately 7,600 revolutions per minute. The 800 revolutions per minute difference between those two engines isn't a software calibration change. It reflects physical differences in the valve train geometry, the camshaft profiles, the combustion chamber design, and the manufacturing tolerances that Honda built into the B18C5, specifically to sustain operation at that RPM range. The specific output number is the one that puts the engineering in context. 108 horsepower per liter from a naturally aspirated production engine that cost under $25,000. The Ferrari Testarossa produces approximately 79 horsepower per liter. The Dodge Viper's Vi 10 produces approximately 56. The turbocharged Toyota Supra's 2JZGTE, with forced induction assisting every combustion cycle, produces approximately 107 horsepower per liter at factory specification. The B18C5 matched a boosted Supra engine's specific output from natural aspiration alone, in a car that cost a fraction of the price. Before getting into how Honda reached that number, it's worth stopping on what the engine actually feels like to drive. Below 5,500 RPM, the B18C5 is civil, cooperative, unremarkable. Then the high-lift cam profile engages, and the engine changes character entirely. The intake note sharpens. The power delivery accelerates. The tachometer needle moves with a sense of urgency that most naturally aspirated engines simply don't have. That crossover point is the whole point of the car, and everything in the engineering exists to make it as clean and repeatable as possible. That number came from the hand-ported cylinder heads. Port polishing is the process of smoothing the intake and exhaust port surfaces inside the cylinder head, removing casting roughness, optimizing the cross-section geometry to reduce turbulence in the airflow path between the intake and the combustion chamber valve. In a naturally aspirated engine, cylinder filling efficiency depends entirely on the pressure differential during the intake stroke. A smoother, better-shaped port means more air moves through with less resistance, which means the cylinder fills more completely on every cycle, which means more power without adding displacement or forced induction. It's the kind of preparation that race engine builders apply as a matter of standard practice. It's the kind of preparation that no production car manufacturer applies at scale, because it requires a technician to work each head by hand for hours before assembly. Honda applied it to every B18C5 built, all 3,381 of them. The intake system compounded that advantage. The B18C5 uses individual throttle bodies, one per cylinder, rather than the shared plenum manifold used on the standard B18C1 and on almost every other production four-cylinder engine of the era. A conventional plenum creates shared intake volume that produces pulse interference between cylinders at high RPM, where the timing of each cylinder's intake event starts to compete with the others. Individual throttle bodies give each cylinder its own dedicated air column, eliminating that interference entirely. This is standard architecture on purpose-built race engines. It was almost unheard of on a production car at any price in 1997. The chassis received the same deliberate attention. Honda's engineers added spot welds at the A-pillar base, the firewall-to-sill junction, and the rear bulkhead connections, locations documented specifically in Honda's own collision repair manual for the Type R. These additional welds increase the body structure's resistance to torsional flex under dynamic loading. The stiffness they produce is structural, built into the steel itself, and it doesn't degrade as suspension components wear. A standard Integra repair procedure applied to a Type R body produces a chassis that no longer matches the original specification, which is why Honda included the weld locations in the repair documentation in the first place. The differential was a torsion helical unit, no clutch packs, no friction material, no viscous fluid. Torque's biasing governed entirely by the geometry of worm gears, responding to speed differences between the front wheels. The consequence is a limited slip differential, whose performance characteristics don't change over time. A high-mileage Type R differential behaves the same as a new one, because there's nothing consumable to wear. Then there was the weight. Approximately 45 pounds removed through thinner rear glass, a deleted spare tire, a deleted rear wiper motor and reservoir, and a lightweight battery. The front glass stayed at standard thickness. Safety requirements set the boundary, and the engineering worked carefully within it. Every one of these decisions points in the same direction. The directive was simple. Cost does not matter. Build the best version of this car that the process will support, and build it right. Every North American DC2 Integra Type R ever built came in one color. Championship white. Color code NH-. Not one of several options. Not a default selection that most buyers happen to choose. The only choice across every model year, from the first unit that rolled out of the Sayama plant in 1997 to the last one built in 2001. 3,381 cars, all of them white. That decision wasn't a cost-saving measure. Offering a single color across a low-volume production run doesn't produce the kind of savings that would move the needle on a car built at this scale and specification. Honda didn't do it to simplify logistics or reduce inventory complexity. They did it because the color had a meaning, and that meaning was the whole point. Championship White is the name Honda gave to the white livery used on its factory racing program. Most directly, it references the Formula One cars that Honda powered in partnership with McLaren from 1988 through 1992. Those were the same years that built the engineering methods eventually carried into the B18C5. The same program that developed the high-revving naturally aspirated engine philosophy. The same championship-winning cars that justified everything Honda was claiming about this $23,000 coupe. So, the color was a statement. Every North American Type R buyer was receiving a car whose exterior connected it, deliberately and by name, to that racing history. Not through a badge or a marketing tagline, through the paint itself. The JDM market tells you this was a choice, not a constraint. In Japan, the Honda Integra Type R was available in Sunset Orange Pearl and Milano Red alongside white. Those colors exist. Honda produced them. They simply didn't come to North America. The Championship White monocolor specification was a market-specific product decision, applied to the North American car because Honda wanted the North American Type R to carry a specific identity, one that didn't depend on the buyer's personal taste. That specificity extended to the transmission. There was no automatic option for the DC2 Type R, not in any model year, not for any market. The close ratio 5-speed manual was the only way the car was sold, and the reason comes back to the engine. The B18C5's power advantage is concentrated above the VTEC engagement point, approximately 5,500 revolutions per minute and higher, where the high-lift cam profile takes over and the engine begins pulling toward its 8,400 RPM redline. The close ratio gearbox, with its shorter steps between gears, keeps the engine in that operating range through more frequent gear changes. A 4-speed automatic of the era couldn't manage that function at the same resolution. So, Honda made the decision for the buyer. The car demanded something from its driver. It asked for attention, for commitment, for a willingness to keep the engine working in the range where it was designed to operate, and it was designed only for drivers willing to do that. The self-selecting nature of that requirement was intentional. Honda wasn't trying to sell this car to everyone. They were trying to sell it to exactly the right person. And the color, the gearbox, and the price together made sure that person knew what they were getting. Championship White was a promise, a statement of continuity between a racing legacy and a road car. But as the final 2001 models were leaving the Sayama plant, a decision had already been made in Tokyo that would ensure this color and the philosophy it represented would never appear on an Integra again. The reason wasn't a shortage of buyers. It was something considerably more cold-blooded. In 2001, Honda confirmed what product planners had already known for at least 2 years. The DC2 Integra lineup was ending. Its replacement would be the RSX, built on the new DC5 platform, arriving for the 2002 model year. And for North America, there would be no Type R variant. What arrived instead was the RSX Type S. Here is what the RSX offered compared to the DC2 Type R. More horsepower on paper, less rigidity in the body, more refinement in the cabin, no torsion differential, a wider sales target, no hand-ported heads, better fuel economy, no individual throttle bodies, more colors, no individual engine assembly. The accountants had been given a checklist, and they worked through it thoroughly. On paper, the Type S looked like progress. The K2OA2 engine produced 200 horsepower, 5 more than the B18C5. It was newer architecture, more modern in its calibration, and it sat in a coupe that was quieter, more refined, and broader in its appeal. Honda's product planners had designed the RSX to cover the full volume range that the entire Integra lineup had occupied in a single model, without the manufacturing complexity that the Type R had required. But the 5 horsepower difference between the B18C5 and the K20A2 understates everything that actually changed. The RSX Type S used conventional port injection rather than individual throttle bodies. It was assembled on a standard manufacturing line rather than by individual technicians completing full engine builds. Its cylinder heads were not hand-ported. Its body received no additional spot, welds at the A-pillar base, the firewall to sill junction, or the rear bulkhead. There was no torsion helical limited slip differential. There was no systematic weight reduction program targeting the rear of the car. The RSX Type S was a competent performance coupe by the standards of its era, and it was built to exactly the specification that a standard manufacturing process produces. That is the distinction that matters. The DC2 Type R was a motorsport process vehicle. The RSX Type S was a standard process performance variant. Those are not the same thing, and 5 additional horsepower does not close the gap between them. The reasons behind the decision were commercial rather than engineering. The yen had remained strong against the dollar through the late 1990s, compressing the margin on every Japanese vehicle exported to North America. For higher-priced vehicles, that compression could be absorbed or passed to buyers willing to pay. For the Type R, whose pricing discipline was a deliberate product decision to keep it accessible, the yen pressure arrived with less room to move. The low production volume, approximately 3,381 units across 5 years, contributed very little to Honda's North American sales targets, and the RSX platform required a single successor model to handle the full Integra volume range, which meant the manufacturing provisions that made the Type R possible had no place in the new product plan. None of those reasons involved a finding that the Type R's engineering was obsolete. The B18C5 was not superseded by a technically superior, naturally aspirated successor. The hand-ported cylinder heads, the individual throttle bodies, the tighter manufacturing tolerances, the body stiffening program, the torsion differential, none of these became unnecessary. They became incompatible with volume and margin requirements, and that is a different thing entirely. What followed was 16 years of absence. From the DC2 Type R's final model year in 2001 until the Civic Type R FK8 arrived in North America in 2017, Honda sold no Type R variant in this market. During those 16 years, the JDM market continued receiving Type R vehicles. The DC5 Integra Type R, the FD2 Civic Type R, the FN2 Civic Type R. Honda built them, developed them, and sold them in Japan, while North America received nothing carrying that designation. The decision to withhold those vehicles wasn't engineering, it was market planning. Honda looked at the North American numbers, weighed the homologation cost, and concluded the volume didn't justify the investment. The accountants had walked back into the room, and when they did, the philosophy that had produced the DC2 Type R didn't survive the conversation. The 3,381 production figure is already a small number. The actual survivor count is smaller. Through the late 1990s and into the early 2000s, the Acura Integra ranked among the most stolen vehicles in North America. And the thieves knew exactly what the engineers knew. The DC2 was worth more in pieces than as a whole. There is one specific component on a surviving Type R, a single mechanical assembly, that determines whether a car trading at $60,000 today is the real thing or just a well-painted old Honda. That distinction matters, and it's worth understanding before this story closes. Insurance industry and NHTSA, data from that period document, elevated theft rates across the Integra lineup broadly. The Type R compounded that risk, because its components carried specific value in the modified car market. The B1.8C5 engine, the close ratio transmission, the torsion differential, all of them were sought as transplant hardware. Thieves weren't always taking the whole car. Sometimes they were taking exactly what made it a Type R and leaving the rest. That attrition reduced the survivor population by an unknown but documented margin, and it continues to affect how many clean, complete examples still exist today. What kept the survivors running is the B-Series engine family. The B1.8C5 shares its iron block, its timing belt, its water pump, and most of its accessory components with the broader Honda B-Series used across the Civic Si, the Prelude, the standard Integra GSR, and multiple other applications across 2 decades of Honda production. That shared architecture means the parts ecosystem for non-Type R specific components is enormous. Any mechanic with Honda B-Series experience has foundational knowledge applicable to the B1.8C5 without needing engine-specific training. VTEC solenoids, valve stem seals, timing belt kits, water pumps, all of these draw on a supply chain whose scale is determined by the entire B-Series deployment, not by the Type R's 3,000 unit production. The B1.8C5 specific failure modes are progressive rather than catastrophic. Valve stem seal wear at high mileage produces blue smoke at cold startup, diagnosable long before it becomes consequential. VTEC solenoid degradation produces a loss of high RPM engagement that an experienced ear can identify before any damage occurs. The timing belt is a scheduled replacement item, and on the B1.8C5's inline-4 configuration, it is a straightforward procedure for any Honda familiar shop. None of these failures arrive without warning, all of them are manageable with maintenance. What kept the remaining cars from disappearing entirely was the community that formed around them. Championship, White DC2, owners developed one of the more disciplined ownership cultures in the Japanese domestic market enthusiast world. Registry efforts, documented service histories, original window stickers preserved in glove boxes. The people who kept these cars understood that what they had wasn't replaceable, and they maintained them accordingly. The collector market recognized what the manufacturing process represented before most buyers did. Well-maintained championship white examples now trade above $40,000 to $60,000 in documented auction results, with pristine low-mileage cars commanding more. That valuation reflects a specific fact that the market has absorbed over time. The hand-ported cylinder heads and individual assembly process applied to the B1.8C5 have never been replicated in any subsequent Honda production vehicle for North America. The 2023 Acura Integra Type S carries the naming convention and nothing else. Different platform, different engine, no mechanical continuity, no interchangeable parts. It is a fine car built to modern standards. It is not what this was. Honda proved that front-wheel drive could be taken to the limit, then decided the proof wasn't worth repeating. The DC2 Type R is what happens when engineers are told cost does not matter, and the accountants haven't arrived yet. It's also a document of what happens when they do. Today, a performance car announces its power through a screen, a torque figure on a display, a driving mode selected from a menu. The B18C5 announced its power through sound and sensation, 8,400 revolutions per minute, a hand-finished cylinder head doing exactly what a technician spent hours preparing it to do. That experience wasn't accidental. It was a philosophy, built into the metal itself, and it died the moment volume and margin replaced it on the priority list. That shift didn't only happen at Honda. Toyota faced the same impossible choice with the Land Cruiser 100. And the story behind it is just as cold-blooded. Click the video on screen now to see how they handled it.